Hello and welcome to this short video about NetSim. This is a video series that will be divided into two parts. I recommend you watching this one first, but there will be another part as well. This part is mainly about analyzing your results. So I will try to show you how you can visualize different results from your calculations. And what we're looking at here on my screen is the calculation for a grid outside of Stockholm. So we're just south of Stockholm here. And we have a load case of minus 15 degrees. So this is how the grid is expected to work at minus 15 degrees Celsius. That's not as cold as it gets, but it's the coldest, more stable temperature we get, and that is actually recurring a bit more frequently than the colder minus 20 or so that happens once in a while. On my screen right now, you can see that the pipes are colored in different ways, and these colors correspond to the differential pressure in the grid. So you can see up here that we have an explanation, a legend telling us about these differential pressures. And right now I'm showing it in bars. So we have below 1 bar on the blue, dark blue color. It's down here in a school that has some issues from time to time. The most sensitive customer in this area. And then we have an increasing pressure until we get to the production plant, or the main production plant. We have two production plants in this case. And in this grid, we don't have any external pumping, which of course can be added as well, but in this case, we only have the distribution pumps from these two production plants going. And we have 300 consumers connected in this grid. So as you can see, the total production here is 40 megawatts in the northern plant, and then we have our secondary plant for roughly 2 megawatts of production power, as you can see in the bottom here. The colors that we're looking at can be changed, so you can change a bit what you want to color by and how many colors you want to have. So if we start by changing the number of colors, right now I have colors corresponding to one color per bar. But I can also, for example, decrease this to only 3 colors, and then I can set my own limits. So if I would like to see anything above 4 bar, let's say, then I can easily put in 4 in this limit here. And these 3 colors let you easily see if you're within your set boundaries for your specific grid when you are looking at this. So you will get a green color if you are inside of the bound you've set, and if you're outside of it, it will show up as blue if you go below and red if you go above it. You can also increase these colors quite a lot. Let's go by 16, which is the highest we have automatically at least. And this will give you a different view of the grid, but I would say it's more visual. It shows you usually some interesting things about how your grid operates, and you can get a good feel for it overall. But it's also very hard to read anything very technical into this because the colors are a bit too close together to separate them properly. And it's also these intervals aren't that easy to read either because they don't really define anything that we have any good concept for how it works. So it gets you a good visual view, and maybe it's nice to show how the grid operates if you're discussing general operations and so on. But if you want to get into the technicalities, I think you are better off with fewer colors. And if we go back to the 6 we had, then we will have the 1 bar again per color. We can also change what we're coloring by. So these colors are by differential pressure, as I said. We have a lot of other options. The other one I will look at now is pressure gradient. So this is our pressure loss per meter in this grid. And again, here you can change number of colors and so on. And if we take a look at this, we can see that we have the dark blue lines, which are very low pressure losses. We have the light blue, which are fairly low pressure losses. Then we have green, which is probably not an issue, but could be if we want to connect some more consumers, or if we go down to the coldest cases, if we go to -20 or so, we might start having some issues with pressure losses in these green lines. The yellow ones start being above what we prefer, at least in Swedish grids most of the time. So you can see we have a few yellow lines spread out, and usually this one is the most interesting in this case. We have a pipe here where we have 172 pascals per meter. And the reason this is interesting is because this is a main line, so there is a lot of consumers on this side of the line after the pressure loss happens. So there's a lot of water we're sending through, and it's a lot of clients being affected by this pressure loss. So this can be a limiting factor of the grid. And then we also have them spread out a bit in other places. If we look at the red ones, we're above 200 pascals per meter. And if we look here, for example, we can see that we have this in the to these consumers, and they are usually not a problem because we have the main distribution pump so close. So we always have quite a lot of differential pressure to work with. So even if we have high pressure losses, it doesn't have a big effect. It's just a few consumers connected, and they are placed in a spot that is not an issue usually in the grid. And then we can also look at this. We know that we have the school down here where we have fairly high pressure losses. And if we look on our way there, we can see that we have one red line standing out. And if we look at it, we have 362 pascals per meter. So we have very high pressure losses in this area here. So this is a big reason why we have these issues in this school. Yeah, and these colors can also be done for other properties. I will not go into them now, but temperatures, absolute pressures. So we looked at differential pressure, but we can also look at supply return pressure. We can look at the flow, so there are the velocities in the pipes. But I will not go into that more right now. So I'll go back to the pressure difference that we started with. You also see that we have some information available in these, what we call labels. So these labels have information for specific points in the grid. And you can add these where you want to, so you can just add them to points of interest. And these ones will be saved. So when you return and look at your grid, you can easily bring these up, and you can get some information about what's happening. And in this grid, I have this information put out for the two main production plants, or the two production plants. So you can see how much power we are producing, what supply temperature, and so on that we are working with. I also have it for three other points, which is the pressure maintenance points in this grid. So in the control room, this would be the points where the operators can see the pressure in the grid, so we can easily compare it to their experience with what's happening compared to these calculations. And it's also usually the points that if there are any issues in this grid, these are the ones where it show up, depending on load case and so on. So these are the ones I've chosen, but you can add them as you want to. You can also hover your mouse over an object and get similar information. And the exact information that is shown here can be selected. So if you go here, you can, for example, if you don't want to see let's say the supply pressure isn't that interesting, then you can easily click it and it will change in these labels. And this will also change when you hover the mouse over, so you can choose exactly which information you want to show in each case. So far, we're only looking at the pipes in this grid. We can also look at what we're calling the nodes, or the consumers. So if we press the nodes, I have some settings put in here that I will explain, but you can see that we get nodes. They have different size and they have different colors. I will just add a legend so we can understand what the colors are for these nodes. So first of all, the colors, as you see, they are based on return temperature. So we have differing return temperatures, and this is based on the input data, which will be shown in the other section of this video. You have these return temperatures, and the darker the color, basically the higher the return temperature. So we have potential problems with these consumers, and the lighter they get, the nicer they are to work with. So we have the light orange, which shows us some consumers which are sending back a relatively nice return temperature. And the size of these nodes they are right now scaled on power. So that means the power usage is the scaling factor. So it's very easy to see which consumers are the larger ones and which are the smaller ones. And as you see, the production plants have a large node to correspond to the production, but then we have these bigger consumers as well spread out through the grid. And we have, for example, a lot of very small single house consumers up here, where you can see very small nodes. So on top of these colors, you can also use scaling to get some information. So the pipes right now are scaled on the inner dimension. So the size of the line or the thickness of the line is decided by how large the inner diameter of these pipes are. But you can change this as well if you want to see the amount of flow that you're sending through the pipe, the amount of power or something like this, then you can scale it on that as well. And same for these nodes, you can scale them on differential pressure or maybe return pressure, some temperature, or flow or power. So this together with the colors gives you a lot of values to work with to get a very informative picture of the grid, where you can show a lot of different information in a single picture. And as you maybe saw, we have this color scale here, blue to red. This is our standard color scale, so if you don't want to do any manual settings, this is what will be used. But you can also do manual settings for these colors, which is what I've done for these temperatures. So we have a red scale here, and this scale is made to not clash too much with the pressures we're seeing in the grid, because we want to have a different color scale. So you can set your own intervals. You can also set your own color scales that you want to use. And in this case, we have, as you see, we have an even spread, but we can also go to this. So if you look at the differential pressures here, you can see that we have this middle section, the green one, is much larger. So we have 1 to 4 bars here, and then we have smaller areas going in both directions, because that's where we start having more interest in what is happening. So basically the 1 to 4 bar is, I'm saying here, is okay. It's fine for basically any grid we're working with, and yeah, any operating conditions. It's no issues. And then we have 4 to 5 here, where we start having a bit higher pressure, and so on. And also going down, we can see that we have a bit smaller intervals again there. So we can see that we're below half a bar, for example, in this school. So you can set these limits as you see fit, and these colors, and they are also saved, so you can reuse them at a later time if you want to. Okay. On top of this map and the visualizations you can do here, you can also do a few other things I want to go through. So we can do a graph of pressure graph, for example, of parts of the grid. So if I press make route here, then I can choose which part of this grid I want to make this graph for. So I'll go from the main power plant to this down here. We'll get a blue indication of where this line is going. And if we go over to the chart part here, then you can see a traditional pressure diagram shown for this area. So you have, in this case, we're looking at relative pressure, so we're not taking height changes into account, which gives us a good view of the pressure drops. So we can see where we have high pressure drops in pipes. And we can also see the differential pressure fairly well between these. But if you want to look into the absolute pressures, the actual supply and return pressure, you can change this here. And then you will get a bit of a different graph. And if we turn on what we call show level, so this is the height curve, then you can see what this depends on, because we have height changes throughout, so we also have corresponding pressure changes. When we go up this hill, we can see that both the supply and the return pressure are dropping. So there you can see the absolute pressures a bit better, but it's harder to see where we have high pressure losses and where we have differential pressures are a bit harder to read on this graph. You can also put on other information if you want to lock the scale on the left. If you want to have a fixed limits, you can put them in. And you can also put in construction curves. So if you want to see if you don't go above your 6 or 10 or 16 bar pressures for your grid, then you can put them in to ensure that you keep below these levels. And we can also put the graph for temperatures and pressure difference, pressure gradients. So we have a few more things we can look at in these graphs if we want to. If you find something of interest that you want to see more of, so if you see, for example, this node in the graph, now we saw that there was a red line in the map, so probably we can figure out where this is. But if we right click on this, we can press show on map. Then we'll have a red indication and a zoom in of the node in question, so we can see where we find this section of the graph in the map as well. I think that's all for this part. We can also see information in tables, of course, which we can copy to Excel. We can also do some sorting and filtering in here, but I will not go into too much detail in this video. Just know that you can see information as numbers as well, not only as graphs and maps. And thank you for listening.